Okay, so we're looking at empirical and molecular formulas, and this would be on page 73 in your IMB. And we have 4 focus questions. How is the molecular formula different from the empirical formula? How do you find the empirical formula? How do you find the molecular formula? And then what do you do if you have an unusual mole ratio? So the first thing we have to understand is the difference between the molecular and empirical formula. The molecular formula is the real-world ratio of atoms. So for example, for H2O, there would be 2 H's to every 1 O. That's the real-world ratio. The empirical formula takes the simplified version of that. So it's the simplest whole number ratio. So we really have to think in terms of fractions. If I have 2 over 4, can that be simplified? Yeah, to 1 over 2. And so we use that concept in order to take the molecular formula and get an empirical formula. So for example, if I have a molecular formula of C2H4, that ratio is 2 to 4. Well, that's not the most simplified form. The most simplified form of 2 to 4 would be 1 to 2. So if I wrote the empirical formula for that, it would be CH2, 1 to 2. So you can see molecular is the real world formula, empirical is the simplified fraction. Another example, though, would be H2O. H2O is its molecular formula. That's the real-world ratio for water. But I can't simplify 2 and 1 to any smaller, so the molecular formula and the empirical formula are the exact same thing. Now, labs oftentimes take unknowns and they're able to do tests to determine the empirical formula, or at least what it's made up of, which can help us find the empirical formula, and then with a little bit of extra info, we can turn that into a molecular formula. And that's what we're going to learn how to do. We're first going to find the empirical formula, and then we're going to use the empirical formula with some extra info in order to get the molecular formula. So let's look at finding the empirical formula. Our question here is in the corner. Find the empirical formula if 40.1% of the compound is sulfur and 59.9% of the compound is oxygen. So our very first step is going to be turn either the percent or the gram, it doesn't matter what they give you in the problem, into moles. So I took 40.1, it was percent, but I said gram, into moles. And so I took 40.1 grams of sulfur and I divided that by its mass on the periodic table. So if I find sulfur on the periodic table, I can see that its mass is 32.066. So I put that in the denominator, I divided the 2 and I got 1.215 moles of sulfur. And then I did the same thing for oxygen. I had 59.9% oxygen, or grams of oxygen. I divided it by its mass on the periodic table, 15.999, and I got 3.744. Step 2 then says to divide all of those answers by the smallest of the answers. So the smallest of the answers is 1.251. So I divide both of them by 1.251. When I do that, I get the answer of 1 and of 2.993. And I chose the 1.251 because it was the smallest of my 2 mole answers. Step 3, round those mole answers to the nearest whole number. 1 is 1, so you're always going to have a value that ends up as 1. And then the 2.993, well, that's really close to 3, so I'm able to round it to 3. There are a couple of exceptions. If this had been 2.5 or 2.3, I would have had to do something else. If it had been 2.5, I would have multiplied both of the numbers, the 1 and the 2.5, by 2. And if it had been 2.3, I'd have had to multiply everybody by 3. But that's only if you get a final divided answer that ends in 0.5 or 0.3. I didn't, so I end up with 1 and 3 as my whole numbers. And so finally I use those to write the formula. That means I have 1 S and 3 O's. So I write it S1O3, and then I find the mass of that. Well, in order to find the mass, I have to use sulfur and oxygen. So sulfur has a mass of 32.066 plus 3 of oxygen, which is 15.999, and that gives me a total of 80.063 grams per mole as the mass of sulfur. So I took the grams, or I took the value that was given, divided by the grams to get our moles, divide by the smallest mole, round to the nearest whole number, write my formula from that, and then find the mass of that formula. And that's how I find the empirical formula. Now, I can take what I have for the empirical formula and find a molecular formula. All right, this is finding empirical and molecular formulas. And so we're going to be looking at the notes that you have on page 73 in your IMB. empirical molecular formulas, and our state standard is P.8.10, which deals with formula representations. We have 4 focus questions that we're answering. How is the molecular formula different from the empirical formula? How do you find the empirical formula? How do you find the molecular formula? And what do you do if you have an unusual mole ratio? So the first thing we need to understand is the difference between empirical and molecular formulas. And really what I want to focus on is this last point in the section. What we do is we take lab information and we turn the empirical formula into the molecular formula. So we start out with the lab information gets us the empirical formula. The empirical formula with a little bit more info gets us the molecular formula. And that's what we're going to do in our practice problems. We'll take that lab info, we'll turn it into the empirical formula using some mole ratios, and then using some mass information, we'll turn it into the molecular formula. So we need to know what is empirical formula and what is molecular formula. Well, molecular formula is the real world ratio of atoms. It's what really happens between atoms when we're looking at a compound. The empirical formula, though, is the simplest whole number ratio. So if you think about in a math class, if you had 2 out of 4, they wouldn't allow you to keep that as an answer. You'd have to do 1 out of 2 because this is the simplest ratio. Well, that's what the empirical formula is going to show. It doesn't give us the whole picture, but it gives us part of the picture by knowing the simplest ratio. So let's look at this example. If I had C2H4 and that was the molecular formula or the real world formula, I'd say, well, what was the empirical formula? Well, a 2 to 4 ratio could be simplified 1 to 2. So the empirical formula for this would be CH2. Now again, remember, we're going to be working backward. We're going to have lab data that gives us the empirical formula, and we're going to use the empirical formula to get the molecular formula. I just wanted you to see the difference between the two. The other part that I want you to see is that there's not always a difference. If we look at the real world formula for water, or H2O, we see that there are 2 hydrogens to 1 oxygen. You can't simplify a 2 to 1 ratio any farther, so the empirical formula is also H2O. So molecular and empirical formulas can be the same, or sometimes they are simplified. Okay, so our most important step, or our most important part today is learning how to find the empirical formula. And there are 4 steps. I'm going to kind of color code those steps. And if you look at the Cornell notes on Schoology, you'll see that they are color-coded for you. So our practice problem, the problem we're looking at today, asks us to find the empirical formula if 40.1% is sulfur and 59.9% is oxygen. And so that's our first kind of piece of information, and this is what's given to us as a problem. So I have 40.1% sulfur and 59.9% oxygen. My very first step is to turn that percentage, or the gram, doesn't matter what they give you, into moles. So they gave me 40.1%, but I'm going to assume a 100-gram sample, so that would be 40.1 grams of sulfur. And I have to divide it by its mass on the periodic table. So if I find sulfur on the periodic table, I can see that sulfur has a mass of 32.066, so that's what I'm going to use for its mass. And so 1 mole of sulfur equals that many grams. When I multiply and divide, I get 1.251. And then I have to do the same thing for oxygen. 59.9 grams of oxygen. I have to divide it by its mass on the periodic table, 15.999. And I get 3.744. So I have 2 answers in the beginning here, 1.251 and 3.744. So then I have to take my second step. My second step is to divide all of them by the smallest. So of my 2 answers, 1.251 is the smaller answer. So I divide by 1.251, I get 1. I divide by 3.744 by 1.251, and I get 2.933. So now I go to my third step. I round to the nearest whole number. Now there's some exceptions here. If I have a 0.5 in the 10th place or a 0.3 in the 10th place, I have to do some multiplication to make the ratios more true, but I don't have that happen here. I have 1 and then I have a 2.9, which doesn't meet an exception. So I just round them to the nearest whole, 1 and 3. So that's my ratio. I have 1 sulfur atom to 3 oxygen atoms, which gives me my 4th step. Write the formula and find the mass. 1 sulfur to 3 oxygens. So I have to get the mass of sulfur and 3 oxygens. So I take sulfur, which is 32.006, plus 3 15.999s, and when I add that up, I get 80.063 grams per mole. So I did my 4th step. So remember, I turn my grams into moles by dividing by the mass on the periodic table. Then I divided by the smallest of my answers. I rounded to the nearest whole number. I wrote my formula, and I wrote my mass. Okay, so that's empirical formula. But most of the time, the empirical formula doesn't really give us anything because it's not the true real-world ratio. I need the molecular formula. So I have a problem. If, using the same information before, I have 40.1% sulfur and 59.9% oxygen, and they tell me that the molecular mass is 160.15 grams per mole, what is the molecular formula? So I can see here that they've added in some information about molecular mass. So what do? 3 steps. The first thing I have to do is I have to start with empirical formula and the empirical mass. So I have already done the problem, so I get to kind of skip a step. I know that my formula is SO3 and my mass is 80.063. So that's step 1. Step 2 is I take the molecular mass, which is given to me in the problem, and I divide it by the empirical mass, which I have found. So the molecular mass given in the problem was 160.15, and the empirical mass that I had found was 80.063. I divide those out and I round to the nearest whole number. This whole number is called n, or my multiplier. Well, I got 2.000, which gives me 2. So now I take n, or my multiplier, and I distribute it into my formula. So I have to take 2 and distribute it into SO3. That gives me S2O6. So my molecular formula then is S2O6. And again, I just want to remind us that after we have divided by the smallest, we have to watch for 0.5s or 0.3s. If we have a 0.5, we multiply all by 2. If we have a 0.3, we multiply all by 3. Okay, so that's the way that we solve the problems. Now we're going to look at a couple of examples. So if you will go to homework E and homework F, we're going to look at the examples there. Okay, so this is homework E. We're going to be working on page 72 in your notebook, and if you've run out of room, please work on another sheet of paper. Okay, so let's look at homework E. I'm going to be doing problem number, I'll just do problem number 1. What is the empirical formula of a molecule containing 65.5% carbon, 5.5% hydrogen, and 29.0% oxygen? Okay, so I have to go through my steps. I know that my first step is going to be to turn the grams into moles. So that's what I'm going to do. So my problem says that I have 65.5% carbon, but I can just write that as grams carbon, 5.5% or grams of hydrogen, and then 29.0% or grams of oxygen. And I'm going to turn all of those into moles. Okay, so for carbon, I know that 12.011 grams of carbon is 1 mole, and that comes from carbon's mass on the periodic table. For hydrogen, I know that 1.008 grams of hydrogen is 1 mole of hydrogen, coming from the periodic table. And then lastly, for oxygen, 15.999 grams of oxygen is 1 mole, coming from the mass on the periodic table. So let me do my calculations. I have 65.5 divided by 12.011, and that gives me 5.453 moles of carbon. Do the same thing for the hydrogen. 5.5 divided by 1.008 gives me 5.456 moles of hydrogen. And then lastly for oxygen, 29 divided by 15.999 gives me 1.813 moles of oxygen. Okay, so I have my moles for each. Well, according to my steps, once I've turned all of my grams into moles, I need to divide by the smallest and then round to the nearest whole number. So I'm going to divide by the smallest and round to the nearest whole number. So my smallest answer here is 0.813. So I'm going to divide everybody by 1.813. And I'm going to get my ratio numbers. Now I'm going to round the ratio numbers to the whole number unless I get something crazy. So 5.453 divided by 1.813 gives me 3.007, which is going to be rounded to 3. 5.456 divided by 1.813 gives me 3.009, which is going to round to 3. And then lastly, 1.813 divided by 1.813 gives me 1. So my ratio is 3 to 3 to 1, which means that I have 3 carbons, 3 hydrogens, and 1 oxygen. So that gives me my empirical formula. Now I just need to find the empirical mass. So carbon is 12.011 times 3, plus hydrogen was 1.008 times 3, plus oxygen was 15.999. So I do that in my calculator. 12.011 times 3. Notice that I'm using the parentheses. Plus 1.008. I forgot the parentheses, so I've got to do it 3 times. Plus 15.999. And I get 55.056 grams per mole as my mass. And so this is my answer. I know my empirical formula and I know my empirical mass. So that should help us with homework E. Okay, now if you'll notice, questions 4 and 5 already are in grams. Not anything different, you just start out in the same place we did with the percentages. Okay, so that's homework E. Let's look at homework F. So homework F is going to be on the back. Sometimes they give you the empirical formula and you move from there, and then other times they're going to give you the information to get the empirical formula and we move on. Okay, so we're going to look at 2 problems. We're going to look at problem number 1 and we're going to look at problem number 3. Okay, problem 1 and problem 3. Okay, so problem number 1. Problem number 1 in homework F says the empirical formula of a compound is CH. The molar mass is 52.07. What is its molecular formula? Okay, well, if I look at the notes, to find the molecular formula, I have to start with the empirical formula, take the molecular mass divided by the empirical mass, and then multiply that number in. So I've already been given the empirical formula. I know the empirical formula is CH, but I need to know the empirical mass. So what's the empirical mass of CH? Well, it's going to be 12.011 plus 1.008. Their masses on the periodic table. 12.011 plus 1.008 gives me 13.019. So I started with the empirical formula and the empirical mass. Step 2 says take the molar or molecular mass, which they gave me in the problem, 52.07, and divide it by the mass that I got for the empirical formula. So 52.07 divided by 13.019, and I get 3.999, which I round to the nearest whole number, 4. And then I take that number and I multiply it back into my formula CH. So I would have C4H4, and that would be my molecular formula. Okay, that was an easier problem because I had the empirical formula. On this third problem that I'm going to do, I'm going to have to start all the way from the beginning. So a chlorinated hydrocarbon compound was found to be 24.4% carbon, 4.04% hydrogen, and 71.72% chlorine. The molecular mass was 99 grams per mole. Find the empirical and the molecular formulas. So I'm going to start all the way at the beginning and then work my way to the molecular formula. Okay, so let's start with 13. I have 24.4%, which I said I can treat as grams of carbon, 4.04 grams of hydrogen, and 71.72 grams of chlorine. So I go ahead and I do my molar ratios. I know that carbon is 12.01 grams on the periodic table. Hydrogen is 1.008 grams per mole. And chlorine is 35.453 grams per mole. Okay, so I'm going to get my answers. I take 24.4 divided by 12.011 and I get 2.031. 4.04 divided by 1.008 gives me 4.008. And then lastly, 71.72 divided by 35.453 gives me 2.022. Okay, now I take my 3 answers and I divide by the smallest. My smallest is 2.022. So I'm going to divide everybody by that. Okay, so 2.031 divided by 2.022 gives me 1.004. That doesn't fall into my exception of being a 0.3 or a 0.5, so I can just round it to 1. My 4.008 divided by 2.002, or I'm sorry, 4.008 divided by 2.022 gives me 1.98, which is the nearest whole number. That doesn't, it's not a 0.3 and it's not a 0.5, so I can round it to my nearest whole number of 2. and then 2.022 divided by 2.022 is 1. So my empirical formula is CH2Cl, and I have to get its mass. So that's going to be 12.011 plus 1.008 times 2 plus 35.453. Remember, all of these masses are the ones from the periodic table. So I'm going to add those up in the calculator. 12.011 plus 35.453, and I get 49.48. Okay, so now I have to go back to my problem because I have my empirical formula, I have my empirical mass, but I have to look back at my problem. Problem number 3 says that the molecular mass was 99.0 grams per mole. So I have to take my empirical formula, my empirical mass, and find the molecular formula. I know from the notes that if I have the empirical formula and I have the empirical mass, I just take the molecular mass given to me in the problem and divide it by the empirical mass that I found to get my multiplier, or my N. So the problem told me the molecular mass was 99.0 grams per mole. I divide that by the mass that I had, 49.48 grams per mole. And when I do that, 99.0 divided by 49.48. I round that to the nearest whole number, 2.00008 rounds to 2, so that's my multiplier. So CH2Cl, I have to multiply that whole formula by 2, so I get C2H4Cl. 2, and that is my final answer. Okay, so if you will use this to work through your notes, and answer homeworks E and F, you should now be proficient at empirical and molecular formulas.